This is a normal curve. A normal curve is an important class of density curves, and they describe normal distributions. All normal curves have the same overall shape. They are symmetric, unimodal, and bell-shaped. In a normal curve, the mean mu is located at the center of the curve and is the same as the median. Changing the mean moves the curve along the horizontal axis. The standard deviation, which is located at the inflection points of the normal curve, controls the spread of a normal curve, as shown in this diagram. The orange curve has the largest standard deviation, while the green curve has the smallest standard deviation. A normal distribution with mean mu and standard deviation sigma is abbreviated as In a normal distribution with mean mu and standard deviation sigma, approximately 68% of the observations fall within one standard deviation of the mean. Approximately 95% of the observations fall within two standard deviations of the mean. And approximately 99.7% of the observations fall within three standard deviations of the mean. This is called the empirical rule.
The question reads, scores on the Wechsler Adult Intelligence Scale, a standard IQ test for the 20 to 34 age group, are approximately normally distributed, with the mean at 100 and the standard deviation at 25. What percent of people aged 20 to 34 have IQs below 100? And so we know that we want to use a normal distribution to solve this question. So when showing work on an FRQ, as we said before, you first want to state the distribution and values of interest, like we do here. You can do this by drawing a picture of the normal curve and restating the mean and the standard deviation, which we have done here in multiple forms. Additionally, you want to indicate your boundary, x equals 100, and the direction with which you want to find the probability. Because the question asks for the percent of people aged 20 to 34 who have IQs below 100, we go to the left. And it's really important to take in the context and understand what the question is truly asking, because it would be tragic if you were to find the probability of people aged 20 to 34 who have IQs above 100. And so now we want to show work, and there are two different methods. So one of them is using the green sheet, or otherwise using the table of standard normal probabilities. And so to do this, first we want to compute the z-score. And so we know the z-score is equivalent to x minus mu over sigma, and so plugging everything in, we get negative 0.4. And then now we know that we want to find the probability of x is less than 100, or which is the same thing as the probability of z is less than negative 0.4. And again, by writing it out this way, we're again demonstrating that we understand the direction and the boundary. And so looking at the green sheet, we find that this probability is 0.3446. The second method is using your calculator. Apart from calculating the z-score and using the table of standard normal probabilities, you can use your calculator. And here I will show you how to do this question with the TI-84. And so under the distributions, you just press second vars. There's this command called normal CDF, and this is the one you want to use. And so for this, I already have the values entered already, but what this function essentially does is that it calculates the area under the curve of a normal distribution when you specify the distribution and give the boundary. So you'll input your lower and upper boundary. So since we're finding x is less than 100, our lower boundary is just a really, really large negative number, so I picked negative 10,000. And then our upper boundary is 100, because if we see from the picture, this is what we want. And then we specify the normal distribution. The mean is 100 and the standard deviation is 25. And then when you hit paste, it essentially computes the area under the curve for you, and we get a very, very, very close answer to that of the green sheet method. And when you show work using your calculator on your paper, you can do it as I have shown here. So you write like the probability of x is less than 100 is equal to normal CDF, and then you want to label the different components, like lower is negative 10,000, upper is 100, etc., etc., and then you have your answer. And showing your work like this should get you full credit. And then finally, what you want to do is answer the question in context. A common mistake is that people might forget to answer the question in context and just have like 0.3446. So to answer the question in context, like shown here, 34.46% of the people aged 20 to 34 have IQs below 100. And solving a question like this should get you full credit on the AP test.
Now we're going to use normal probability plots to determine whether distribution of data is approximately normal. When the normal probability plot is linear, a normal approximation is appropriate for the data. For data skewed right, the normal probability plot will curve out to the right, while a plot for data skewed left will curve out to the left, as we can see in the diagram.
By the way, here are some good College Board FRQs for practice listed below. Thanks for watching!